Good afternoon, 8th graders. Just wanted to jump on here and give you a video on the lab that is due on Friday. So this Friday the 29th, we will be working on a lab for chemistry. This is all virtual, so there is a place in here where you can actually do some of these if you have the household materials, but you do not need to do that. The lab report can be completed with the help of the virtual lab. So as you see over here on the left-hand side, I have the lab open to the investigation portion, page 3 of 4 here. We're going to be looking at some different splint tests. On the right-hand side, you will see the lab report, and I have moved the lab report to the same lesson as the lab, so you won't have to go into two different places to find the lab report for the lab. So let's go ahead and get started. We're going to be looking at a couple of splint tests. So this basically means in this first video that oxygen is going to be the gas that is released. So watch carefully what happens when oxygen gas is released to the flame. Okay, so you should notice that when oxygen was released, then the match stayed lit. Even when it was going out, they put it back into the oxygen and that reignited the match. Okay, the next one is hydrogen. So this is what happens when hydrogen is released. So as you can see, if hydrogen gas is released, then the flame goes out pretty violently as well, because you probably could hear that popping sound as well when the flame went out. And this one is for carbon dioxide. So when carbon dioxide is released, this is what occurs. All right, so from those splint tests, you can tell that when carbon dioxide gas and hydrogen gas are released, the flame goes out. And when oxygen is released, then it is flammable and it will keep the match going. So please keep that in mind as we move into our lab. So on page 4 of the lab, this is the virtual lab right here, as you can see on the left. It also has a procedure for you to do if you have these items in your kitchen. But again, you do not, I repeat, you do not have to do the actual lab. You can stick with the virtual lab and fill out your lab report very easily. So the first question, what is the purpose of this experiment? So we are going to look at simulations to conduct splint tests to identify the gas produced in a chemical reaction. So right up here above the procedure, we're going to use the simulation to conduct a flaming splint test to identify the gas produced in a chemical reaction. That is the purpose of our experiment. Number 2 says, how can you identify the gas produced in a chemical reaction without observing the atoms and molecules directly? Well, you can identify those gases based on if the match here that you see in the virtual lab stays lit or if it goes out. So you can make some predictions about if it's oxygen gas being released or if it is hydrogen or carbon dioxide gas being released. So you are going to write a hypothesis based on the observation. So basically our hypothesis, we are going to be looking at adding baking soda and an effervescent tablet, which is like an Alka-Seltzer tablet, to water, vinegar, and lemon juice. So in your hypothesis, you can basically state that if oxygen gas is released, then the flame will stay lit, or if carbon dioxide or hydrogen gas is released, then the flame will go out. So that would be your hypothesis. The tools that we're using here today is a flask, and we're also using a match. Okay, so that's actually a tool today because it will actually tell us what type of gas we are releasing. So both of those, a flask and the match would be our tools. All right, very simply enough, guys, the procedure is listed here on the left-hand side, 1 through 5. So you can just simply copy paste those into experimental methods number 2, describe the procedure, because it tells you step by step exactly what you are to do. Chemistry experiments are usually like this. They have a very specific procedure. Again, we're looking at things that could be very volatile or explosive. So it's very important always in the chemistry laboratory to make sure that you are wearing safety goggles if you are actually doing the experiment at home, as well as following the directions carefully because you could be looking at something with some pretty volatile properties. All right, so we are going to make our data table. So data and observations number 1, again, you're going to go up here to the insert, and the insert will have a drop down that has table right here, and then you will just add a table and place it under data and observations number 1. All right, so here we are going to, in our table, put down the products, the reactants, and then you're also going to say whether the flame went out or the flame was more ignited. Okay? All right, so we're going to go to the lab. It says select vinegar to add vinegar to the Erlenmeyer flask. So we're just going to click on the vinegar. As soon as you do that, it adds a sample into the flask. Select and drag the baking soda to the liquid. So you're simply just going to take the baking soda and drop it in. And you will notice that a gas is released. So we are going to pick up the match and place it over the flask, and it went out. Okay, so because it went out on your data table, you're also going to put whether you think it is hydrogen carbon dioxide gas or oxygen. So I'm going to go ahead and create a table. Okay, and mine comes up here to the top, so you can move that as you need to. And we're going to put chemical reaction. We're going to put reactants. Remember, the reactants is what goes in. We're going to put products. And let's see, flame. So this is out or not out. And then gas released. Okay, so the chemical reaction, the first one we did, the reactants were vinegar and baking soda. Okay, the products were a gas. The flame went out, so we know from that it would have to be hydrogen gas released or carbon dioxide. Okay? Then it says, repeat the experiment with 2 different combinations of liquids and solids. So we're just going to hit this little round arrow, and that will take us back to the to set it up again. Let's see, I'm going to try lemon juice and add an effervescent tablet. Okay, so we can see that it produces a gas, and it made the match go out. So our second reaction was lemon juice and I'll just put effervescent tablet as ET. A gas was produced, it went out, so we know this has to be either hydrogen gas or carbon dioxide. Okay, and then you are going to do one more of those. Okay, so you need to make sure that you probably add some to your data table, and you need to also do a third reaction. If you want to do 4 or 5, you're welcome to do that too. Just make sure it looks very similar to the data table that I have here. All right, so after you look at a few of those, we're going to make some conclusions about the identities of the gases produced in the chemical reactions. So again, remember guys, a conclusion needs to have both a qualitative and a quantitative part. So qualitative is just the words that's describing, and then the quantitative, you need to make sure that you back it up with numbers. All right, so basically the only numbers in this are the numbers of the chemical reactions, but you do need to make sure that your qualitative part is very specific. So I would say something like vinegar and baking soda produced a gas that had to be hydrogen or carbon dioxide because the flame went out. Lemon juice and effervescent tablet produced a gas, which would have to be hydrogen or carbon dioxide because the flame went out. Okay, and then if you have some reactants that's a product and the flame got larger, then you would just, or the flame continued, then you would just say whatever and whatever mixed together produced a gas. I know it had to be hydrogen, and the reason I knew that is or it had to be oxygen, and the reason I knew that is because it stayed up. Okay? All right, so that will get us to this last question. And again, make sure that you remember what we have been looking at. And it says, so based on your observations between the reaction of vinegar and baking soda, which equation best models that reaction? Okay, so I want you to actually think about this question on your own. There is one that you can take out automatically because of what happened in the reaction. Okay, then I want you to then look at the other 3 reactions and see if you can figure out by the use of the equation, make sure that it's balanced like we've talked about, if you can figure out what the right answer is, and then explain. In your explanation, make sure that you discuss whether the flame went out or it stayed lit, and that will be the explanation of what gas was released. Okay, guys, I hope this helps. Again, this lab is due this Friday, the 29th. So please make sure that you watch this video. Stop it whenever you need to stop it and start it so you can get your lab report completed. Thank you guys so much and have a wonderful day.